Hello everybody, today we're going to talk about Z-Wobble, something near and dear to all of our hearts, I'm sure. Specifically how it pertains to the Lulzbot Taz printers. The Taz does not have bad Z-Wobble. It has a little bit, but it's not really any more than any other lead screw equipped printers that are out there currently. My goal though is to eliminate it entirely, so that's what this project is about. Just to show you kind of what I'm talking about here, this is a double bearing holder that was printed with my Taz when it was in the stock Taz 3 configuration, and you can see there's ridges basically here that kind of line up with the actual lead screw thread pitch and everything. This one doesn't exactly match because it was printed on the Taz 3 ones, but you get the idea. So what I started out with, we've got the stock lead screw Z nut. Basically the actual nut for the lead screw bolts onto these things, and these 4 bolts bolt up onto the plate, kind of on the back side there. This is rigid and in place and goes up and down on the lead screw as the printer moves. Works pretty well. The problem with the Taz in particular, and it's not really a major problem, but it is a little bit of a problem, is that plate there, even if you've got it locked down really, really tight on a bearing set like I've got here with the open rails extrusion, it has a tendency to flex slightly. Especially if you're on the stock rods, there's actually about half a millimeter worth of flex that can actually go back and forth, which is plenty. So as you're printing, the tendency for the nut, which has a little bit of backlash built into it, is basically to shunt itself from corner to corner based on the motion of the X and Y axis. Kind of throws the part over one direction or the other, mainly the X axis, but it tends to, as it goes up to one side, then the plane's on the other side, so it moves to the other side and back and forth as it goes up there. So my goal to get rid of it is basically to take that motion effect out of play on the lead screw. So what I did is I came up with this prototype first, and what this uses is basically 4 plastic sliding pins, and it goes back and forth on the actual pins, which works great. The problem is it only affects the X-axis travel. You still have your banding on the Y-axis because there's nothing preventing it to go there. It's a little bit taller than the stock unit, a little bit thicker, but it's not too bad. So I decided that wasn't going to work. I needed something on Y. So I came up with this kind of monstrosity here, and it's basically, there's actually 4 roller bearings down here in the bottom, a couple of actual bolts with heat set insets, a couple on the top there, and it slides back and forth. But there's just too much friction. I could never get this one to work really well, and also getting those bearings in there was a pain if you ever have to actually disassemble a thing. So, I mean, it works, but it wasn't great. So I abandoned that approach. And then the next one I came up with was kind of like this same slider approach, but it's actually got a U-shaped piece, and it's what's on there currently. The problem with that unit was that as the lead screw goes up, it can actually turn in those channels, so it would actually eliminate some of the Y wobble, but at the same time it introduces another problem where it can actually go up and down. So that approach didn't work. So then I came up with, let's use steel pins and a sliding block. So you have the same pin design as above, just able to go X and Y, and then you've got the sliding pin down here. The problem with this particular variant of it is that I could never get it precise enough to actually not introduce a bunch of extra wobble in the actual unit. If I made it too small and drilled it out, I couldn't get the drill precise enough even with the drill press. If I made it too tight, it just had too much friction. So it wobbled and basically had a lot of Z motion, so it didn't really work out too well. So what I ended up coming up with was using some IGUS insert bearings, and they're basically little split ring bearings, and I printed out the middle section here with a retainer ring and a channel, so the bearing just kind of sits in there. There's 2 per side on each of the 2 sides there, and basically that goes in there, rod goes through there, works really, really well. So to give you a whole idea how this whole unit works, you've got this plate here, which is a stock Taz 4 or 5 plate, and I've replaced the bolts and the heat set inserts with these bolts and these pins. So the anti-wobble mount can go in or out as it needs to, but it can also slide up or down. So basically, no matter what the lead screw wants to do as it's going up, it can go in or out and not affect the plane of the motion at all, but it can't go up or down more than it's supposed to be. So it locks it pretty much exactly in place. This will fit a stock Taz 4 or 5. The main differences here is the double nut holder. You do have to replace that just for clearance. The stock one has that second bolt hole that is just too far up and it hits things. And of course you have to print this whole assembly here. The back, this is just pretty much a stock Taz 4 or 5 mounting block here for the motor mount. So we'll go up there. This unit does come in a little bit further into the plane than it did before, but you've got your actual end stop mount here, so the carriage comes over here. It never actually interferes with this, so you don't have to do any other modifications besides printing out the double nut holder here, which is also going to be included in the kit. We'll put the instructions on which actual rods and bearings and inserts here to order. It's basically a 1/4 inch rod. The bolts are 1/4 inch thread with just standard Home Depot issue spacers. Other than that, that's pretty much it. If anybody has any questions or wants to know more details, please feel free to let me know, and hope you enjoy. Thank you.